Okay, so what I want to do here is we've talked a lot about trade-offs, and we have a certain amount of time, amount of resources, and we can only choose what we should do best. And so basically the graphic model of these trade-offs is called a production possibilities frontier, or PPF, more commonly known. And so what a PPF shows is, for example, I need to do my homework, usually, or I can watch a show. I like to watch a lot of different things. My favorite show is probably Psych of all time. But, so let's draw my PPF. Okay, so I could either watch a show, or I can let's label this as homework. Okay, so let's say I have a total of 10 hours to spare. On my day. So I could spend, let's say it's like a Saturday. I could spend all 10 hours watching a show, or I could spend all 10 hours doing homework. And then we draw this line in between, and this line kind of indicates how we split up our time. So we could be like, for example, this could be like 5 and 5. Wow, that is not a good. There you go. And everything in between. So like right here is like maybe like we spend 7 hours doing homework and only 3 hours watching a show, and vice versa. So we have this kind of trade-off, and this is our opportunity cost. The slope of this line is our opportunity cost, and as you can see, this is a straight line. So that means our opportunity cost at every single point stays the same, because our slope, if we were to draw a tangent line to each of the points, the slope stays the same. So what this means is, how we know it's a straight line, we're looking for words like perfectly interchangeable. Okay, that is a key indicator that we're dealing with the straight line, a perfectly linear slope. So now let's talk a little bit about the points on a PPF. Okay, so we're going to look at 3 points. We're going to look at this one, we're going to look at this one, and we're going to look at this one. Okay, so so this point is basically this whole region below the line is what we call inefficient, because we have, in this case, like for example, let's look at this red point. We extend it out, right? This point right here. So that point, that's like if we decide to spend, I don't know, like 3 hours and 3 hours. 3 hours doing homework and 3 hours watching a show. And then we just spend the last 4 hours just sitting in silence. So the reason it's inefficient is because we have another 4 more hours we could be spending to do whatever we want to, whether it's doing homework or watching a show, but we're being inefficient because we're not using that time, those resources, when we easily could. It wouldn't cost us anything additional. We wouldn't be trading off anything in order to do it. I could still watch 3 hours of a show, but I could do another 4 more hours of homework, and vice versa, and I wouldn't be trading off. That's why it's inefficient. Okay, now we're going to look at this point. We're going to label it blue now. So basically any point on the line is now what we call efficient. That means we are maximizing all of our resources, all of our time, to produce whatever we want, or to use whatever we want. In this case, I'm spending all 10 hours that I have to spare to watch a show or do homework. Okay, and anything in between then, if I wanted to like move things around, which I could, it's still efficient use of my time, but it has a trade-off. I can't increase the amount of homework I have without giving up time on the show. And then finally, we have this last point, which is basically any point beyond the line is what we call infeasible. Okay, and the reason this is infeasible is because, like, this is an example of, I don't know, we'll say this is 5 hours. Let me draw this point right here. 5 hours of homework and 11 hours of show. Obviously, we can't reach this point because we only have 10 hours to spare. And that's a sum of 16 hours. So that's why it's infeasible. We'd have to create some sort of time machine, or we'd have to create more hours, more resources in general. And so the only way that we can reach infeasible points is by shifts in the PPF. And typically what we look at, what could cause a shift in the PPF is, so let me go right here. Is we're typically looking at tech advancements, like I talked, as I mentioned before, like if we had some sort of time machine or some way to do homework faster, so that way we don't have to spend a full hour doing homework, and we could do homework half the time, or maybe just watch shows on 2 times speed, things like that. So some sort of technological advancement. Or sometimes we have shift inwards of the PPF, and this could be, I don't know, like natural disasters, basically any loss or gain of resources. Now, a common mistake, which we want to make sure we don't do, so I'll put this right here, is this will not shift the PPF is if we reallocate resources. So let's say we can either produce bread or we could produce, I don't know, bagels. If we have a lot of bread workers and a lot of bagels, so like a lot of bread workers and a lot of bagel workers, but bagels now become more popular, so we move some of our bread workers to bagel workers. That's movement along the PPF because we're just reallocating because we have a total sum of workers. And that's, for this example, it's like if we move some of our hours of homework to instead to watch more shows. So I'm just going to label it as a movement / reallocation of resources. Okay. So yeah, this is kind of our introduction to a PPF. I'm going to talk a little bit in the next video. I don't have enough time because I try to keep the videos under 10 minutes. But next, we'll talk a little bit about the sloped PPFs and then also how to interpret the opportunity cost on the sloped PPF. Adam, out.